Hello guys, my name is Simon and welcome to another video on ALS software engineering program. Today we'll be looking at the even more pointer array and string. This is a very important topic and I will try my best to do more explanation and look into more examples. So the first thing I will do is to go to the resource section and I want to open this in a new tab. Alright, there's a concept they want us to understand in this project. This is C pointer to pointer. And what is this? So the C pointer to pointer is a pointer which is pointing to another pointer. For example, pointer A is pointing to pointer B and pointer B is pointing to a variable, is holding the value of a variable. Right, sorry, is holding the memory of a variable. Alright, so for us to actually have a clear understanding of this, I'm going to copy this and run it in our online compiler. But however, I urge you to look into the resources. You can pause the video and go back and look into the resources so that you read everything here, that you can have a proper understanding of the summary they are giving in here, and it will also help when you are looking at the example I am actually giving. It will give you a clear picture of everything. So I'm going to copy what I have here and open in an online compiler. Okay, this is for Python. I'll open a one for C. Okay, so I'm going to remove what is there by default and Ctrl V to paste what I have copied from this page here. So back to programming, I want to run this code, but before I run, I want to do some explanation here. You can see in line 5 we declare a variable, right, of type integer, and in line 6 we also declare a pointer of type integer. Then in line 7, I want you to take note of this. This is a pointer with 2 asterisks. This is how to declare a double pointer. Okay, it has 2 asterisks. A double pointer has 2 asterisks, while a single pointer has 1 asterisk. So in line 9, you can see what we are doing here. We are assigning the value 3000 to the variable. Then in line 12, we are assigning the pointer, which is the single pointer, to hold the address of the variable. Then in line 15, we can see the double pointer is holding the address of the single pointer. So we are going to run now and let us see what we get. So if you look at the console, right, we can see the value, which is the variable we've declared here. The value of a variable is what? 3000. That was assigned in line 9. Then if you look at the value of the single pointer, right, is also 3000. So you can see we're able to access the value of the single pointer, and we're also able to get the value of the variable, right, the value of the variable from the double pointer using double asterisk. You can see that on the console here. So you can see everything is holding the value, which is 3000. So if you want to get the value from a single pointer, you use 1 asterisk and a formatting type of D. Is going to give you the value of the variable. Then if you want to also get the value from a double pointer, you use the formatting type, which is D, and the double pointer. One thing I want you to note here is this value here is the value of the variable. So if you want to print out their own memory address, right, if you want to print out the memory address of each one, so this is what you do. Use the ampersand symbol and change this to P. Okay, Then for this, you can use the ampersand symbol too. Then change the identifier to P. I'm gonna do the same thing here. Do the same thing here and the same thing here. So if you run, you can see they all have different memory allocation. So this is the memory address of each item. So you can see we're able to define the memory address of each item. All right, let us look at some other examples. Okay, going back to the project page, and I want to open the other one, which is C pointer to pointer with example on a new tab. All right, so here is talking about what we've one of the examples we just declared now. So to declare a double pointer, right, we use 2 asterisks. You can see the example right here. They are using 2 asterisks and the pointer type is an integer. So another thing I want you to do is to study this diagram. You can see there is a value, right? There is a variable called num, which is an integer, and the value of the num is 1 to 3. The variable num has an address. You can see the address here. It has an address. Okay, then this is the address of the variable num. Then you can see there is another variable which is a pointer, right? This pointer is holding the address of holding the address of the num. Okay, and why there is another pointer, this one is called double pointer. Okay, so this one is holding the address of PR2, and PR2 is holding the memory address of num. Okay, so if we scroll down a little, I want to copy this and run it on the console. I'm going to copy this. Excuse me. Copy to the top. Okay, so Ctrl C to copy. Go back to my online compiler. Ctrl A to highlight everything and C to erase. Then Ctrl V to paste. Alright, so let us see what's going on here. In line 4, let me clear this. In line 4, you can see there is a variable called num, and the variable type is an integer, and the variable num is holding a value 1 to 3. Then in line 7, we declare a pointer. It is called pointer2. Sorry, it is called PR2. You can see a single asterisk, so it shows that this is single pointer. Okay, and in line 10, you can see we are declaring a variable which is of type integer, and it's a double pointer. How do we know it's a double pointer? You can see the 2 asterisks there, just like I have shown a few minutes ago. A double pointer can be declared by using 2 asterisks. Then in line 15, okay, this is something need to happen here. Okay, let me just read this. Assigning the address of the variable num to the pointer 2. Okay, so what we should do is to assign the address of variable num. So to do that, we use the ampersand sign and the variable num. So what we are doing here is we are assigning the address of num to pointer 2, which is the single pointer. Then if you look at line 20, right, so what we are doing here is to assign the memory address to pointer 1. So this one is a double pointer. PR1 is what? A double pointer. I want you to take note of that. You can see that in line 10. PR1 is what? A double pointer. So now the printout will actually throw more understanding. But if I run this now, let me run this. Okay, good. Everything is good. I think everything here is too they are too close to each other, so let me do something like this. It should be /n or /n. Okay, I want to add a space in between. Okay, so I think that is all. So let me run. Excuse me. Okay, oh sorry, this should be printf, not print. Sorry about that. Printf. One more. Okay, so if I run this program, and you can see, if you look at the left hand side of my screen on line 23, you can see the value of num is what? 1, 2, 3 is 1, 2, 3, and we can also access the value of num from pointer 2, which is the single pointer, right? So the value is also what? 1, 2, 3, which is the value of num. Again, we can also access the value of 1, the value of num, num, from the double pointer, which is this. You can see here we're using a double star and p arrow 2. You can see it prints out the value. If we go to the next section, you can see these are the possible ways to find the address. So if you look at this, if you look at this, and this is what you see here, this is the address, this is the memory address of num, which is num. Okay, so you can see this is the address, and if you look at this, we're able to access the address of num from PRO2, which is the single pointer. You can see this address is the memory address of num. We're able to access the address of num from the double pointer. So how do you do that? You can see using a single star, right? So we're able to access the address here, and if you look at this closely, you see this, all the address we have here are the same, and it belongs to one variable, and that one variable is num. So if you look at this, okay, you can see so we're able to find the value of pointer 2, the value of what? Pointer p arrow 2, which is this. So if you look at this, this is the value, right? So you can see it's holding the memory address of what? Of num. If you look at this previous one here, you can see this number are the same. This memory address are the same. Okay, you can see the memory address are what? Are the same. And if you look at these two, you can see it's also the same with this. So we're able to get the address, we're able to get the value of the single pointer using single asterisk, right? So that is why you are seeing this value as the same. Okay, so the double pointer is holding the value of the single pointer, which was done here, on line 20. Okay, in the other part of the application, in the other part of this section, if you look at this, and we're able to find the address of the pointer. So this is the address of the pointer p arrow 2. So this is the address of the pointer p arrow 2. We're able to get the address of p arrow 2, which is the single pointer here. So if you look at this, this is the address. Excuse me. This is the address of the single pointer. Okay, so lastly, if you look at the value of pointer p arrow 1, which is this, is different from the value of the double pointer, sorry, the memory address of the value pointer. So if we want to access the value of the double pointer, we can do like this. We can use the ampersand and it will print out the value of it will print out the memory address of the double pointer, but this time it's printing the memory address of the single pointer, and you can see it on the console. So the last one is the memory address of the double pointer itself, and you can see that right here. Okay, so you can play around with this, and it can give you a clear understanding. Well, however, if you want to access individual address, okay, let me remove this part. You can see we have none. If you want to access individual address, you can do this, the ampersand of none, the ampersand of PRO2, which is a single pointer, and the ampersand of the double pointer. But I need to change this format to P, and to P. If you run this, so you can see these are the individual address of these variables. Okay, so that is for this section. Let me also go back to the project page that we can look into more examples. Okay, the next one is multi-dimensional array. Let me open this in a new tab. Okay, so when it comes to multi-dimensional array, one thing I want you to understand is a multi-dimensional array is I can explain it like an array in an array. Right, so it has a child inside, which is an array, and he himself is an array. Right, it's a variable which is an array, then it also has a child inside, which is an array. All right, you're going to see that example. Okay, let me just copy this. Let us go to the online compiler. So I'm going to clear my screen and this. So let me just call this array. Okay, so if you run now, nothing happens. Okay, so okay, sorry, let me use other example. I think this one is, let me look for other examples. Yes, I think this one is better. Okay, this one is better. Okay, so let me remove this. Excuse me. So if you take a closer look, sorry, let me zoom out it. If you take a closer look, and you will see that we have a variable called an array, and the variable type is an integer, and there's a 2 square bracket. What this means is it's going to be a parent array and a child array, right? So this is saying I'm going to have a parent array of 5 lengths, then inside it I'm going to have a child array which is 2 lengths. So for the 5 lengths, this is the first length at index 0, then this is the second length at index 1, this is index 2, index 3, and index 4. So remember, an array starts from index 0. So 0 to 4 is what? 5. 0 to 4 is 5. And for the child array which is inside, so what I'm going to have is 2. You can see 2, 2, 2, 2. So all the child inside will be what? 2, 2 at index 5. Okay, so now to have a proper understanding of this, we need to access the value of this item. So what if I want to access the value of the first item? How do I do that? Okay, let me print out on the console. So our type is integer d. Here is an integer, so that's going to be %d, %d, %d. So if I do array of O, an array of O is this. Okay, but before you can print an array, before you can print a list of array or an array in C, you have to do a loop. Okay, for me, I actually not find a way to loop through to see how we can print an array, but we can only print a single value. Okay, so but I want you to take note that the first index of this array is this, and the second index of this array is this, and the third index is this, and so on and so forth. Okay, then to access the first item, which is the first array, in the first array I want to access the first item. So to access the first item, we have to be array of index O. This is the first array of index O, and in the child array you have to be O. Array of index 0, and what? The child array of index 0. So if I run that, it should give me 0. So you can see it gives me what? 0. But what if I want to access the second item of array at index 1? So all I'll do is to change here to 1. Then I'm going to come here. This will also be what? 1. If I run this, it should give me what? 2. You can see it gives me 2. What if I want to access the first item in this array? So what I will do is to change here to what? 0. And if I run this, you can see it gives me what? 1, which is the first item. What if I want to access the last item? The last item, the last value in the last child array. So first I need to count the index. This is index 1, index 2, index 3, index 0, index 1, index 2, index 3, and index 4. So what I will do is to put 4 here, 4, and to print the first item, this is index 0 and this is index 1. So this can also be index, so this have to be 0, which is the 4 item. Then this should be 1 to print the last item. So this should give me what? 8. If I run this, you can see. Good. So what if I want to increase the size of the child array? We can increase this to what? 3. So this means that for every sub array it should be 3 items. So I'm going to make it 3 3. Change it to 3. Change it to 3, and the last one we should change it to 3. So if I run this, it doesn't change anything, right? It will still give me 8. If I run, it give me 8. What if I want to print 7, which is not the last item, right? So you can see this is index 0 of the last item. This is 2. So this is 1 and this is 2. So what I will do is to put here 2, and if I run, it gives me what? 7. Alright, so what if I want to access this 9 here? How do I do that? So the first thing we do is to count the outermost array, which is the parent array, index O, index 1, and index 2. So you change here to what? 2. Then you need to count the child index, O, 1, 2. So this should be 2. So if I run, it should give me what? 9. If I run this, and it give me what? 9. So what if I want to change the value? What if I want to change the value? This 0 here, which is the value of the second index of the child array. So how do I do that? I can do that like this. I can say array of what? You need to know the parent index, the parent position first. So this is index what? O. So if you do this O, then which of them do you want to change? This is index O, this is index 1, and this is index 2. So I want to change index 1. So for index 1, I'm going to put 1 there, and I want to change it to 55. So let us print the index 1. So area of index O and 1. If we run that, it gives us what? 55. You can see we're able to modify the value, we're able to change the value. So I hope this gives a clear example on a multi-dimensional array. So this is a 2D array. So let's look at other examples. Okay, so on the last part, you can see this is two-dimensional array. Of course, we've talked about it, but let's just open it in a new tab. And let's see what we have. Possibly we can have some example to look at. Okay, good. So this talk about how to print an array. You know, like I said, I don't have I have not really found like how to print an array in a straight line, just like how we are doing it in Python. So you can see I think what they are doing here, they are assigning a value into an array and they are printing. So let us run it on the console. So if we run, you can see I'm going to enter 3, enter. So this, now we have entered the value at index 0 of 0, 3. So for index 0 of 1, I want to enter 2. Okay, index 0 of 2, I want to enter 4. Of index 1 at 0, I want to enter 8. Array of index 1 and 1, I want to enter 2. So I'm going to enter my value like that. You can see it prints out the value on the console. Okay, so this is basically an array of 2 lengths. So we can see this will be equal to, you can see this will be equal to an array of 2 lengths. An array of 2 lengths will be like this. Then let me enter the same value we've entered here. So this will be like this: 3, 2, 4, then another one here, and 8, 2, 3. So this is basically the same thing I have entered here. Okay, so that is all for this video. I hope this is helpful. So we are going to go to the quiz and project section. Alright guys, welcome to the quiz section. And what I will do is to expand my quiz. You can see the first one, they're asking what is the size of star p in this code, which is asterisk p in this code. So obviously, okay, I think this should be this, which is double asterisk. So this is what? 8 bytes. All right, so next, if we, so they're asking what is stored inside a pointer to a pointer to an integer. Of course, we discussed about that. So it is an address, where an address is what's stored. So the #2 question, it says in the following code, what is the value of a of index 0 and index 0? Obviously you should know is the first one, which is this. You can see is this. We've talked about that. Okay, so if I scroll down, for this, it says what is the size of p in this code. So we should know that the size of p is this. Then the next one, which is the #4 question, says in the following code, what is the value of a index 1 of 1? Of course, we should know that is this. This is the index they're talking about, index 1. And for index 1, inside we have O and 1. So you're talking about 1 of 1. So it is this. Okay. That's for that. So if I scroll down, so here they are saying what is the size of asterisk p in this code. Okay, we've known that this is this holds the address of, this is a pointer, right? So it's an integer. It's not a double one, this is a single pointer, so it's an integer. Then the question as she says, what is the size of p in this code? Okay, so we can see this is a single pointer, right? It is a single pointer, and this is the correct answer because this is going to point to an address. So they are asking of p. In this one, they are asking of what? The pointer, right? For year, they are only talking about what? P, year. So we should know the difference. Okay, so if I scroll down to question #7, or the question #7, so they say in the following code, what is the value of a index 3 index 1? So the first thing you do is to look at index 3. This is 0, 1, 2, 3. So this is index 3. Then it says index 1. This is 01. So this is what? The correct answer. And question #8 says in the following code, what is the value of index A3 and index 0? Obviously this should be what? 7. Okay, if I scroll down, okay, we are done with the quiz section, so we're going to move to the task section. Welcome to the task section. The first thing I want you to do is you want to read all the requirements, if any. Okay, so if there's no requirement, the next thing to do is to log into your terminal. How do you do that? You need to go to your sandbox section and click on new tab. I'm going to open my terminal. So for me, I prefer to use the SSH. So I'm going to copy my SSH and I will just paste it here and press enter. It's going to prompt me for password. I'm waiting for it to prompt me for password. Okay, good. So it's asking me to input my password. What I will do is to copy my password. I've copied my password. I'm going to paste it here. Then I press enter. So let me expand the screen. And increase this. Okay, good. So you can see we are here now, and the first thing to do is to go to your project folder. So I'm going to my project folder. Okay, my own is located at els/example, sorry, root/example, so els low level programming. I want to see what I have in my project folder. Good. So if you go back to the project page, you can see for this, the first thing you should do, sorry, let me hide this first. Let me hide the quiz section. ensure you read these general requirements. It's very important. There are some key things there, though it might look the same every time, but there are some key things you need to know. So you can see we need underscore pucha. You are allowed to use underscore pucha. Then you can see the prototype of all your function and the prototype of the function underscore pucha should be included in the file main.h. Don't forget to push your header file. I just prefer to push everything. And you can see in the following example, right? In the following example, the files are shown as example. You can use them to test your function, but you don't have to push them to your repo. If you do, we won't take them into account. We use our own main.c file as compilation. So you can ignore the example file, or you can decide to push. You can decide to push it just like how I am doing. You don't need to learn about pointer to function, array, or structure of malloc yet. I prefer you to learn it. Okay, so let us go to the task. The first thing you want to do is to create your folder. Okay, so you can see we are already in this folder, right? So we want to create this folder. What you do is to copy the name of the folder, because if you type it, you might make a mistake and run into error. So what I will do is to use mkdir, paste the name of the folder. You can see the folder has been created, no error. Then I want to go into that folder, which is OX07. Then I'm currently in the folder. So if you go up, you can see there should be a readme file, which is mandatory, right? So I want to create my readme file. For that, I'll do readme.md. So for my readme.md, I for insert, and what I will do is array pointer project /2d array, escape wq to write. Okay, if I check now, you can see I have my readme here. Okay, if we go to our project folder, and you can see for this, the prototype is very important. So it has what? A prototype. Okay, so you need to create a file main.h. Remember the name here, they said main.h. Okay, so you need to create a file vim main.h and include all the prototype like this. All the prototype like this. All the prototype like this. So but I'm not going to save this because I already have my own. Okay, so so I'm gonna quit. Okay, sorry. Let me just I'm gonna remove that file. So let me remove the main.h. I don't need it. So I'm gonna copy my own main.h that I already have. Put that for my main project. It should be ALS low level programming language OS-7. Then it should be main.h. Sorry. paste and copy it here. So if I clear, I should now have a new main.h here. So you can see, let me see what we have in the main.h file. You can see I already have all my prototype in here. Okay, so for that, the next thing I will do, is, so for here they said the mset function, the underscore mset function fills the function n by bytes of the memory area pointed by x. Write the constant byte b, return a pointer memory. So they want us to write this file, this file. So you need to create this file. So let me just copy my own that I already have. I'm going to test it and make sure it's working properly. So then I'm going to copy o-mset. So let me call the name again. Okay. .c. Copy it in the current folder. So if you check now, okay, you can also see the content of my own. Oh, sorry. You can see this is the content of my own. So I'm going to clear. Then once you've written yours, you can do Betty o-main.c and check if everything is okay. You can see there's no error. It shows my own is okay. The next thing I want to do is to test the file. So you can see, if you go to here, you can see they're giving us a file which is o-main.c. I want to create that file, and to create that file, I'm going to create that file. So I to insert, then I'm going to copy the content of that file. I believe it ends here. So I'm going to do Control to copy everything. Okay, I think I've copied it very well. Then go back to my terminal, paste it here. Escape WQ. So I want to test my file and make sure everything is okay. So if you see, good. So I now have the test file and my written file, which is o-memset.c. So to test the file, this is what I will do. I'm going to copy this line. This is the GCC, and this is what I will do. Paste it on the command line and press enter. So if everything goes well, there will be no error, and it's going to generate a file, an executable file called 0-memset. So if you check now, you should see the file 0-memset. So I'm going to run this file o-memset. So if I run, you can see it prints out exactly the same result we have here. So the reason for testing is you are sure everything is okay, and the next thing you want to do is to do git hard git commit -m done with first tags. You can write any message you want, then you can do git push. Okay, so once you're done with git push, the next thing you want to do is to click on check your code. You can start new test. Alright, so I'm not going to do this because I'm already done. You can see mine is already checked as done. Let us look at the other one, which is question 1, which is memc. I'm going to clear the console. So this says write a function that copies the memory area. There's a prototype. So now what you do is to update your header file. So if we check, I already have that header file here in main.h. You can look at the name, which is _memc. So if you look at here, you should see _memc, which is this. Okay, so it says the memc function copies n byte from memory area source to memory area DST. Return a pointer to DST. The standard library provides a similar function, memc. Run man AMC to learn more. Okay, so they say there's a similar function, so you can run this to learn more. Okay, you can run this to learn more. Okay, so that's for that. You can look at this, you can look at it if you want. Okay, you can look at this and see, you'll be able to understand what is going on. So I'm going to quit and erase and clear my screen. So now let us create this file, which is 1-mem.c. So to create this file, all you need to do is to do your vim, or anyone you're using could be vi, and create this file. So I'm not going to create this file, I already have it. Let me just copy it. Let me copy that file. Okay, I'm using the up arrow to look for my previous copy command. Okay, good, I've seen that. So if you look at the name of the file, it's called 1-memc. So to do that, I'm going to do 1-memc.c and copy it here. So once I copy that here, and once I've copied that here, and the next thing I want to do is to check the file with Betty. So if I do ls-l, you can see this is the file I just copied now, 1-memc. So the next thing to do is to check with Betty if the file is okay. Betty, you can see there's no complaint, it shows the file is okay. So next you want to test that file. You can see they're giving us a test file. Okay, so if you go, this is it. Ctrl+C to copy. For this test file, this is what you do. Enter. And for the test file, we want to copy here, from here upward. Okay, copy here and paste. Okay, so we already have our test file. And the next thing we want to do is to test our test file. Is to test our solution with our test file. So what I will do is to do copy the gcc command and paste here. So if I run, you can see there is no error, and if I do ls, you can see it must have generated a file called 1-memcpy. ls-l. So this is the 1-memcpy. The final step is to test your solution if it's going to output the same result as this. So we want to run the 1-memcpy. So I'm going to do -memcpy. 1-memcpy and run. So if you see, you can see that mine is giving the same result as what we have here. So I think these two examples is enough to continue. So let me just show you how your project will look like when you're done. So okay, let me show you how it look like. Okay, so let me just go back. Okay, so let me remove this folder. Arrow. -07. So I remove everything about that folder, everything including the folder itself, everything inside and the folder itself. So to see how your project will look like, let me show you. I'm going to copy from my main folder. So what I will do is erase this. So I'm going to copy everything. Okay, no source file or directory. Okay, yes, sorry, I need to remove one more step. So if I do ls-l, so and I go into the folder -07. So let me clear. So this should be ls-el. So this should be how your project should look like when you are done. You can see all the executable files are here, and all your files you've written also are here. You can decide to push everything just like I'm doing, or to hide all your executable file, you can create a file called .gitignore. So if you don't, any file you don't want to push to the cloud, you can copy this name and put it inside. So instead of using Vim, instead of using Tosh, you can just use Vim. So anyone you don't want, you can copy it and put inside. Definitely it's not going to appear on your GitHub. Okay, so that is all for this video. If you find this video helpful, please make sure you subscribe, make sure you like, and I'll see you in another video. Thank you very much for watching.